Hi, we are back with lesson 6-2. And again, we're not using the Springboard textbook to do these examples. Another operation you can perform with functions is called a composition. And this is when we use a function as the input of another. And so we are going to look at a couple different notations. The composition of functions g of x with f of x is written like this. H of x equals, we read that g of f of x, or h of x equals, and you'll see g with this little open circle, f, and that's also the same. That's still g of f of x. So one notation's a little nicer because you can actually see f of x is going to be into the g function. This one you just kind of have to remember the second function goes into the first function. So we're going to practice that with two functions that have been given to us. So we have function f of x, which is x plus 2, and g of x, which is x squared plus 6. And we'll just kind of practice putting one function into the other. We're going to start with f of g of x. So basically that means the g function, which is x squared plus 6, is going to go into the f function in place of x. So where we had an x, we're going to put an x squared plus 6. But then there was already a plus 2 there. So we just combine like terms and we're done. X squared plus 6 plus 2 is x squared plus 8. Okay, and that's all we have to do for part A. Now part B uses a different notation, but I like to rewrite it always with the notation you see in part A because I think it's more intuitive. So g of f of x is g of f of x. So basically that means now we want the f function into the g function. So the f function was x plus 2. It's now going to go in place of x in the g function. So the g function was x squared plus 6. We're going to put the f function in there. And it's a little more work now to simplify because we have to square that binomial. So we're going to do x plus 2 times x plus 2 before we add the 6. So we get x squared plus 2x plus 2x is 4x plus 4 plus 6. And finally, x squared plus 4x plus 10. Okay. Sometimes you're asked to find f of g of a value. And so, like for part C, we have to find f of g of 3. So the other notation would look like this, f of g of 3. And we'd want to start by finding g of 3. So when we find g of 3, okay, so let's do g of 3. That's going to be 3 squared plus 6. 9 plus 6, 15. So we found g of 3. Then we take that output and we make it an input into the f function. So I want f of 15, which means the f function is x plus 2. So I want 15 plus 2, 17. And that becomes our final answer. For part D, we want to do the opposite and find g of f of 3. Now, do you think that g of f of 3 would be the same as f of g of 3? They sound alike. Well, let's see what happens. First, we want to find f of 3. So we'll start with that. F of 3 is 3 plus 2, which is 5. Then we find g of 5, which is 5 squared plus 6. 25 plus 6, we get 31, which is not the same. F of g of 3 and g of f of 3 are not the same for this situation. Okay, now you have some for you to try. So if you would like to pause the video and give these 3 a try, and then I'll go through them with you. All right, so first I want to find f of g of 5. Nope, I want to find g of f of 5 first. So let's do f of 5. So f of 5 is 3 times 5 minus 8. 15 minus 8, 7. Then I need to find g of 7, and that's 2 times 7 squared. 2 times 49, 98. Well, f of g of 5, maybe that's also 98. Let's see. This time I find g of 5 first. So 2 times 5 squared, 2 times 25, I get 50. Then I get to do f of 50. That is going to be 3 times 50 minus 8, 150 minus 8, 142. Again, not the same. The last problem in this set is asking us to find g of f. So again, we're going to go back and use a function as input. G of f of x. We're going to put the f function, which is 3x minus 8, in place of x in the g function. The g function is 2 times x squared. Caution not to distribute the 2. Remember, you must do the power first before you distribute. And this is a 3x minus 8 quantity squared. So we have to do 3x minus 8 times itself. And when we FOIL, we get 9x squared minus 24x minus 24x is minus 48x. And negative 8 times negative 8 is positive 64. One more step will be a distributive property. So 18x squared minus 96x plus 128. So the last part of this lesson starts to talk about domain and a little bit of range for when we're when working with a composite function. We're also we want to make sure we consider the domain. Most of the time this is what x has to be or what x maybe can't be, whichever is easiest to describe. They give a couple examples, and so I'll kind of talk about that a little bit. Our functions here include a squared function, which, any x can be squared. There's no restrictions on x there. However, in a square root, there are some restrictions. Remember, a square root must always remain positive. So whatever's inside that square root has to be greater than or equal to 0. And so I want to set up x minus 4 must be greater than or equal to 0. Now, if I were to solve this, I would add 4 to both sides. So x must be greater than or equal to 4. Okay, that's part of our domain. And that might change a little bit based on, when we do our composite functions. But for right now, our x must be greater than or equal to 4. Anything less than that will create a negative in the radical. All right, so if we were to do some compositions now, for example, we have f of g of x. So if I were to take the g function and plug it into the f function, remember the f function is x squared. Well, x squared, if I plug in the radical that they gave me for g of x, that's x minus 4 squared. Well, a square and a square root cancel each other out, and I just get x minus 4, which seems to be fine for domain, because any x you can subtract 4. Well, that's why we include the domain x must be greater than or equal to 4 in order to handle the inside function. So for domain, you must consider the inside of the function too. Now, usually we don't worry about the radicals. We more or less talk about the fractions is what you're going to see at our level. We'll get more into the radicals in advanced algebra. So let's look at one more example. It says let f of x be 1 over x, and g of x is x minus 2. So x minus 2, there's no restrictions because you can take any number and subtract 2, and it won't be an undefined expression. But 1 over x, you gotta make sure that denominator is not 0, because 1 divided by anything, 1 divided by 0, anything divided by 0 is undefined. So we need to make sure that x is not equal to 0 in this situation. Okay, so that's going to be part of our domain. Sometimes it's easier to list the number it can't be rather than what it can be. So let's find f of g of x. F of g of x means the g function goes in place of x. So that's going to be 1 over x minus 2. Well, for this situation, the 0 would be fine. However, there's another number that creates a problem, and that number is 2, because 2 minus 2 is 0, and we can't divide by 0. So we want to put down x cannot be 0, and x cannot be 2. And now we have got our domain all set. So we'll talk more about domain. It only comes up when we're doing division of our compositions, or division of our functions, or a composition with a problem like this. So it doesn't come up a lot. And that's all I want to do for this note